780,000 years ago, something happened that should have wiped us out completely. Picture this. You are standing on a hillside in what we now call Israel. The year is approximately 780,000 before the present day. Above you, the sky is doing something it has never done in your lifetime, or your parents' lifetime, or in the lifetime of anyone your people have ever known. The stars are visible during the day, not faintly, but brilliantly, burning through a sky that has somehow become thinner, weaker, less protective. At night, the auroras are not confined to the far north or south anymore. They dance directly overhead in ribbons of green and purple and red, beautiful and terrifying in equal measure. Your skin tingles constantly. Not from heat or cold, but from something else, something invisible that seems to press down on you from above. Animals are acting strangely. Birds are flying in the wrong directions. Some of the elders in your group have developed strange sicknesses, their skin marked with burns that came from nowhere. Several children were born recently with deformities your people have never seen before. And then there is the thing that no one talks about but everyone feels, the thing that has been happening slowly over generations, but is now undeniable. The world's protection is failing. Earth's magnetic field, that invisible shield that has always stood between you and the full force of the sun's radiation, is collapsing. This is not speculation. This is not ancient mythology or campfire storytelling. This actually happened, and we have proof. In 2004, archaeologists working at a site called Gesher Benot Ya'aqov in Israel made a discovery that should have rewritten every textbook about human prehistory. They found something that was not supposed to exist: hearths, fire pits, evidence of controlled, sustained fire use dating back 780,000 years. But here's what makes it remarkable. This was not a one-time accident, not someone getting lucky with a lightning strike. This was sophisticated fire technology maintained across multiple generations, with clear evidence of fire being used for cooking, for tool making, for protection, and possibly for something else entirely. The site sits right on top of geological layers that correspond exactly with one of the most catastrophic events in Earth's recent history: the Brunhes-Matuyama magnetic reversal. The last time our planet's magnetic poles completely flipped positions. Now, you might be thinking that magnetic pole reversals sound like something out of a disaster movie. You would be right to think that. Except this is not fiction. These reversals happen. They have happened hundreds of times throughout Earth's history. And 780,000 years ago, right when our ancestors were supposedly just beginning to figure out how to be human, the planet decided to pull the rug out from under them. During a magnetic reversal, Earth's protective magnetic field does not just weaken slightly, it can drop to as little as 5% of its normal strength. For thousands of years, some estimates suggest the transition period lasted up to 10,000 years. Imagine 10,000 years of our planet being essentially naked to cosmic radiation. 10,000 years of solar wind bombarding the surface with particles that would normally be deflected safely away. 10,000 years of radiation levels 10 times higher than normal. This should have been an extinction event. This should have killed everything that could not hide deep underground or underwater. But it did not. Humanity survived. Not only did we survive, but something else happened during this period. Something that anthropologists and evolutionary biologists have struggled to explain for decades. Our brains started growing fast. Between 800,000 and 600,000 years ago, human brain size increased dramatically, jumping from an average of about 900 cubic centimeters to over 1,100. That is a 20% increase in brain volume in what amounts to an evolutionary eye blink. The mainstream explanation is that this was just natural selection, just the normal course of evolution favoring intelligence. But there is a problem with that explanation. Brain tissue is expensive. It requires an enormous amount of calories to maintain. In a world where food is scarce and survival is a daily struggle, growing a bigger brain is actually a disadvantage unless that bigger brain is giving you something incredibly valuable in return. Something worth the extra 2,000 calories per day it costs to run the thing. So what changed? What made it worth it? Here is where things get interesting, and controversial, and potentially unsettling. There is a theory, not widely accepted in mainstream academia, that the magnetic reversal itself might have been the catalyst. High levels of cosmic radiation are known to cause mutations. Most mutations are harmful or neutral, but occasionally, rarely, you get one that provides an advantage. What if, during those 10,000 years of elevated radiation, our ancestors experienced a mutation rate far higher than normal? What if the very thing that should have killed them instead rewired them? The timing is too perfect to ignore. The magnetic reversal, the sudden leap in brain size, the appearance of sophisticated fire technology, the evidence of coordinated group behavior and forward planning, all of it happening in the same narrow window of time. And here is something else that does not get talked about enough in popular discussions of human evolution. Around this same time period, geneticists have identified what they call a population bottleneck. That is a fancy way of saying that humanity nearly went extinct. The genetic diversity of modern humans suggests that at some point in our past, our total population dropped to maybe 10,000 individuals. Some estimates go as low as 2,000. 2,000 people, that is a small town. That is everyone you could fit into a high school gymnasium with room to spare. We were on the edge, and somehow, we pulled back. But what if we are not getting the full story? What if there is evidence that has been overlooked, ignored, or deliberately set aside because it does not fit the narrative we have been telling ourselves about our own origins? Welcome to Tales Before Tesla. I am diving deep into the mysteries that conventional history prefers to keep buried, the questions that make academics uncomfortable, the evidence that suggests our past is far stranger and more complex than we have been led to believe. If you are ready to explore the margins of accepted history, to question the stories we have been told, then you are in the right place. Go ahead and subscribe, hit that notification bell, because we are just getting started. And trust me, where we are going next will challenge everything you thought you knew about what it means to be human. Now, back to 780,000 years ago. Back to that hillside in Israel. Back to the fire. Because there is something about that fire at Gesher Benot Ya'aqov that bothers me. Something that should bother you too. The archaeological team that excavated the site found evidence of fire use across multiple occupation layers. That means people came back to this spot again and again, over potentially thousands of years. They maintained knowledge of fire keeping across generations, passing it down from parent to child, elder to youth, in an unbroken chain. But why there? Why that specific location? The site is situated near ancient lake shores and wetlands, in an area that would have been rich with resources. Good place to live, certainly. But here is the thing. It is also one of the few places in the region with natural rock shelters and caves. Deep caves. The kind of caves you would want to be in if the sky itself had become dangerous. The kind of caves that would shield you from radiation. Is it possible that our ancestors understood, on some level, that the world above had become hostile, that they needed protection not just from predators and weather, but from something coming from the sky itself? We know that ancient peoples were incredibly observant of natural phenomena. They tracked the stars, predicted seasons, understood animal behavior in ways that would put most modern people to shame. Is it really so far-fetched to imagine they noticed the auroras spreading, the strange effects on animals, the increase in sickness, and connected it to the sky? And if they understood the danger, what else did they understand? What other knowledge did they possess that we have lost, that has vanished from the archaeological record because it was passed down orally, or because it was recorded in materials that have long since decayed? This is the question that haunts me as I dig deeper into this period. Not just what happened 780,000 years ago, but what are we missing? What pieces of the puzzle have been lost to time, and which pieces have been deliberately pushed aside? The thing about apocalypses is that we imagine them happening quickly. A meteor strike, a nuclear war, a plague that spreads in weeks. We picture the end of the world as something sudden, dramatic, something you could point to and say, this is when everything changed. But the most terrifying apocalypses are not like that at all. The most terrifying ones happen so slowly that each generation thinks the world has always been this way. They happen over lifetimes, over centuries, over thousands of years. And by the time anyone realizes what is happening, it is far too late to stop it. 780,000 years ago, our ancestors lived through exactly that kind of apocalypse, and most of them probably died never understanding why. The Brunhes-Matuyama reversal was not an event, it was a process. A long, grinding, catastrophic process that took somewhere between 1,000 and 10,000 years to complete, depending on which geological studies you trust. During that time, Earth's magnetic field did not simply flip like a switch, it weakened, it fluctuated. It developed multiple poles, sometimes 3 or 4 at once, causing the field lines to twist and contort in ways that left vast regions of the planet completely unprotected. Let me put this in perspective. Right now, as you are watching this, Earth's magnetic field extends about 60,000 kilometers into space. It is strong enough to deflect most of the charged particles that the sun constantly hurls at us, particles traveling at speeds up to 2 million miles per hour. Without this shield, those particles would strip away our atmosphere, bombard every living thing on the surface with radiation, and turn Earth into something resembling Mars, a dead rock with a thin, useless atmosphere. During the reversal, this protective bubble shrank. In some places, it disappeared entirely. Studies of volcanic rocks from this period show that the field strength dropped to less than 10% of normal levels. Some estimates put it at 5%. Imagine your protection against cosmic radiation being reduced to 1/20th of what it should be, for thousands of years. The effects would have been immediate and devastating. Cosmic rays, normally deflected by the magnetosphere, would have penetrated deep into the atmosphere. This would have caused a cascade of effects. Increased production of radioactive isotopes like beryllium-10 and carbon-14, higher rates of cloud formation, potentially triggering rapid climate shifts, increased UV radiation reaching the surface, and perhaps most critically for life, a dramatic spike in mutation rates across all species. Now here's where the official story gets interesting. And by interesting, I mean suspiciously quiet. If you go looking for information about what the Brunhes-Matuyama reversal did to life on Earth, you will find a lot of papers assuring you that it probably was not that bad, that life is resilient, that there is no clear extinction event in the fossil record tied directly to this reversal. The message is clear. Do not worry about it. These things happen. Life goes on. But if you dig deeper, if you start looking at the data rather than the conclusions, a different picture emerges. Multiple studies have found evidence of increased extinction rates in marine organisms around 780,000 years ago. Certain species of plankton disappeared. Coral reefs went through a die-off period. Deep-sea sediment cores show disruptions in the populations of organisms that are normally incredibly stable. On land, the picture is harder to read because the terrestrial fossil record from this period is fragmentary at best. But what we do have is suggestive. Megafauna populations seem to have contracted. Some species disappeared from regions they had inhabited for millions of years. And perhaps most tellingly, human populations crashed. That genetic bottleneck I mentioned earlier, the one that reduced humanity to a few thousand individuals, lines up almost perfectly with the Brunhes-Matuyama reversal. The timing has been confirmed by multiple independent studies using different methodologies. Around 800,000 to 700,000 years ago, something culled the human population down to a tiny remnant. We nearly went extinct. The mainstream explanation is climate change. The world was going through glacial cycles, ice ages coming and going, and sometimes conditions just got too harsh. Resources became scarce. Competition intensified. People died. It is a clean, simple explanation that requires no unusual factors. Just the normal brutality of nature doing what nature does. But here is what bothers me about that explanation. Humans had already survived multiple glacial cycles by this point. Homo erectus had been around for nearly 2 million years. Our ancestors had spread across Africa and into Asia. They had adapted to everything from tropical jungles to temperate grasslands. They were survivors, generalists, the kind of species that should have been able to weather a climate shift. So why did this particular period almost finish us off? What made 780,000 years ago so uniquely deadly? Unless it was not just climate change. Unless there was something else happening. Something invisible. Something that did not leave the kind of fossil evidence that paleontologists know how to read. Radiation damage does not fossilize well. Mutations caused by cosmic rays do not show up in ancient bones. The effects of living under a weakened magnetic field for generations would be written in DNA, not in stone. And conveniently, DNA from 780,000 years ago does not exist. It has long since degraded beyond recovery. We are left with fragments, statistical analyses, genetic modeling based on modern populations. We are trying to reconstruct a crime scene after the evidence has been washed away. But there are hints. Tantalizing, frustrating hints that something profound happened to humanity during this window of time. First, there is the brain size increase I mentioned earlier. But it is not just that brains got bigger, it is how they got bigger. When you look at the pattern of brain evolution in hominins, you see a gradual increase over millions of years. Slow, steady, predictable. Then, around 800,000 years ago, the rate accelerates. Brain volume shoots up faster than at any other point in our evolutionary history. And then, around 600,000 years ago, it stabilizes again. That is not what gradual natural selection looks like. That looks like a punctuated event, something that applied intense selective pressure for a relatively brief period, favored certain traits dramatically, and then released that pressure. Second, there is the sudden appearance of new behaviors in the archaeological record. Controlled fire use at Gesher Benot Ya'aqov is the most famous example, but it is not the only one. Around this same time, we start seeing evidence of long-distance resource transport, raw materials being carried dozens of miles from their source to habitation sites. That implies planning. That implies mental modeling of terrain and resources. That implies a level of cognitive sophistication that earlier hominins simply did not demonstrate. We also see changes in tool technology. The Acheulean hand axes that Homo erectus had been making for over 1,000,000 years suddenly become more refined, more standardized, more carefully crafted. It is subtle, but it is there. Something changed in how these people thought about tool making. And then there is the elephant in the room, literally. Several sites from this period show evidence of systematic elephant hunting, not scavenging, not opportunistic kills. Systematic, coordinated hunting of the largest land animals on the planet, elephants that would have weighed 6 to 8 tons. This requires planning, cooperation, communication, and the ability to think several steps ahead. It requires a kind of intelligence that we previously did not think existed until much later in human evolution. So we have a population crash, a brain size increase, a behavioral revolution, and a magnetic apocalypse all happening in the same narrow window of time. And we are supposed to believe these things are unrelated? Here is where I need to be careful. Here is where I need to draw a line between what we can say with confidence and what is speculation. Because the idea that cosmic radiation might have accelerated human brain evolution is not proven. It is not accepted by mainstream science. Most paleoanthropologists will tell you that correlation does not equal causation, and they are right. Just because these things happened at the same time does not mean one caused the other. But it is a hell of a coincidence. And here is what makes me suspicious about the mainstream reluctance to even consider this possibility. We know that radiation causes mutations. This is not controversial. We know that most mutations are harmful, but some provide advantages. We know that periods of environmental stress accelerate evolution by applying strong selective pressure. We know all of these things. So why is it considered fringe or pseudoscientific to suggest that a 10,000-year period of elevated radiation might have played a role in human cognitive evolution? I think part of the answer is that it makes people uncomfortable. It suggests that human intelligence, the thing we are most proud of, the thing that makes us special, might have been the result of something random and catastrophic rather than a steady, inevitable march toward greater complexity. It suggests we got lucky, that we are the descendants of the few who happened to have the right mutations at the right time to survive what should have killed us all. And maybe there is another reason for the silence. Maybe, just maybe, some people in positions of authority do not want the general public thinking too hard about magnetic reversals. Because here is the uncomfortable truth. It is happening again. Earth's magnetic field is weakening. Right now, as you watch this, the North Magnetic Pole is moving faster than it has at any point since we started keeping records. It is currently racing across the Arctic at about 30 miles per year, accelerating from the 9 miles per year it was moving in the early 1900s. The overall field strength has decreased by about 10% over the last 2 centuries. Some regions, particularly over the South Atlantic, have developed what scientists call anomalies, areas where the field is significantly weaker than it should be. Satellites passing through the South Atlantic anomaly experience increased radiation exposure. Airlines have started routing flights to avoid it when possible. The International Space Station has to shut down non-essential systems when passing through it. Are we heading toward another reversal? The official answer from institutions like NASA and NOAA is maybe, but do not worry. These things take thousands of years, and we will have plenty of time to adapt. The unofficial whispers among some geophysicists are less reassuring. Some data suggests the field decay is accelerating. Some models predict we could see a reversal begin within the next few centuries, maybe sooner. And if it happens, if we end up living through what our ancestors lived through 780,000 years ago, we are far more vulnerable than they were. Our technology depends on satellites that would be fried by increased radiation. Our power grids could be knocked offline by solar storms that the weakened magnetosphere cannot deflect. Our food production systems are centralized and fragile in ways that hunter-gatherer societies never were. Our ancestors survived by hiding in caves, keeping fires burning, and passing knowledge down through stories. Could we do the same? Would we even know how? These are questions that make people in power uncomfortable. These are questions that do not have reassuring answers. So instead, we get papers explaining that everything is fine, that magnetic reversals are natural and not really that dangerous, that we should not worry about it. But 780,000 years ago tells a different story. It tells a story of a world pushed to the edge, of populations crashing, of only the most adaptable, the most innovative, the luckiest surviving. It tells a story we should be paying attention to. Because the thing about slow apocalypses is that by the time everyone realizes what is happening, it is already too late to prepare. Because the thing about slow apocalypses is that by the time everyone realizes what is happening, it is already too late to prepare. Quick question before we move on. Where are you watching from? And what time is it there? I am genuinely curious whether you are starting your day with this or falling asleep to stories about magnetic apocalypses. Comment your location and time. I want to map out where this information is spreading. Fire is older than humanity. Lightning has been setting forests ablaze for hundreds of millions of years. Volcanoes have been spewing molten rock since the planet cooled enough to have a crust. Fire is not special. Fire is just chemistry. Rapid oxidation, carbon bonding with oxygen, releasing energy as heat and light. Any animal with eyes can see fire. Any animal with skin can feel its warmth. But controlling fire? That is different. That is not chemistry. That is technology. That is understanding cause and effect. That is planning for tomorrow based on what you learned yesterday. That is the difference between an animal and something else. Something new. For most of the 20th century, archaeologists believed that fire control was a relatively recent innovation, maybe 400,000 years ago, maybe 500,000 at the earliest. The evidence was thin, scattered, ambiguous. Burned bones here, some charcoal there, but nothing definitive, nothing that proves sustained. Intentional use across generations. Then came Gesher Benot Ya'aqov. The site sits in the Hula Valley in northern Israel, right along the ancient route that connected Africa to Eurasia. 780,000 years ago, this was prime real estate. A freshwater lake, surrounded by wetlands, teeming with fish and waterfowl. Gallery forests along the shores. Open grasslands beyond, where herds of elephants and wild cattle grazed. If you were an early human looking for a place to settle, this would have been on your short list. Archaeologists had been working the site since the late 1980s, pulling up stone tools and animal bones, the usual stuff you expect from a Paleolithic site. Then, in the lower layers, in deposits dated to around 780,000 years ago, they started finding something else. Concentrations of burned material, not random scatter from a brush fire, not the aftermath of a lightning strike. Organized hearths, fire pits with clear boundaries, clusters of burned flint and wood showing repeated use in the same locations. The team spent years analyzing this material, ruling out every possible natural explanation. They looked at magnetic signatures in the burned clay. They examined the temperatures required to produce the specific types of charring they were seeing. They mapped the spatial distribution of burned artifacts. Every test, every analysis, pointed to the same conclusion. This was controlled fire, maintained fire, fire that had been kept burning, fed deliberately, used for specific purposes, and then rekindled again the next day, the next week, the next season. But here is what elevated this discovery from interesting to revolutionary. They found burned food remains, fish bones showing clear evidence of cooking, seeds from wild grapes, charred but not destroyed, suggesting careful heat application, wild barley and wheat processed with fire. These people were not just keeping fire alive for warmth or light. They were using it to transform their food, to make it safer, more digestible, more nutritious. Cooking is not a trivial innovation. Cooking is what nutritionists call an external stomach. It breaks down proteins and carbohydrates before they enter your body, making more calories available with less digestive effort. Raw meat might give you 60% of its caloric value. Cooked meat gives you 90% or more. That difference is enormous when you are living on the edge of starvation, when every calorie counts, when the margin between surviving and dying might come down to how efficiently your body can extract energy from food. And there is something else cooking does, something that does not get discussed nearly enough in popular accounts of human evolution. Cooking kills parasites. It neutralizes toxins. It makes foods edible that would otherwise be dangerous or impossible to digest. It dramatically reduces the disease burden on a population. In a world where your immune system is already compromised by elevated radiation levels, where mutations are running rampant, where every infection could be a death sentence, cooking suddenly becomes more than convenience. It becomes survival. So who were these fire keepers? These people maintaining flames 780,000 years ago while the world fell apart around them? They were Homo erectus, or maybe something transitioning between erectus and an early form of heidelbergensis. The fossil record from this period is frustratingly sparse. We have fragments, pieces, not enough to make definitive identifications. What we can say is that they had brains averaging around 1,000 cubic centimeters, smaller than modern humans, but significantly larger than earlier hominins. They walked fully upright. They had hands capable of fine manipulation. And based on the evidence at Gesher Benot Ya'aqov, they had cognitive abilities that we seriously underestimated for decades. Consider what fire maintenance actually requires. You need to understand that fire consumes fuel, that it needs to be fed regularly or it dies. You need to know which woods burn best, which create the most heat, which produce the least smoke. You need to protect the fire from rain and wind. You need to make decisions about when to build up the flames and when to let them burn low. You need to transport embers if you are moving camp, keeping them alive in some kind of container until you can establish a new hearth. All of this requires planning, memory, communication, and knowledge transmission. You cannot figure this out alone. Firekeeping is a social technology. It requires teaching. It requires language, or at minimum, a sophisticated system of gestural communication. It requires trust, because you are relying on others to maintain something that the entire group depends on. And here is the part that keeps me up at night. How long had they been doing this before Gesher Benot Ya'aqov? Because 780,000 years ago is not the invention of fire control. It is just the oldest unambiguous evidence we have found so far. The technology visible at this site is already mature, already sophisticated. These people knew what they were doing, which means they must have learned it earlier, somewhere else. But where? When? There are hints, controversial, heavily debated hints that push fire control back even further. Wonderwork Cave in South Africa has deposits with burned bones and ash dated to around 1 million years ago. Critics argue the evidence is ambiguous, that it could be natural fire that humans simply took advantage of. Maybe, but maybe not. Zhoukoudian Cave in China, famous as the home of Peking Man, has thick deposits of ash and burned bone spanning hundreds of thousands of years. The oldest layers potentially date back 600,000 years or more. For decades, this was held up as proof of ancient fire use. Then, in the 1990s, some researchers began questioning whether the burning was actually from human activity or from natural cave fires, possibly ignited by roosting bats, whose guano can spontaneously combust under certain conditions. The bat guano theory has always struck me as desperate. You are seriously suggesting that bats set a cave on fire repeatedly for hundreds of thousands of years, and the humans living there just kept coming back to a cave that spontaneously combusted? That they somehow never noticed the correlation? That they never thought to maybe clean out the guano or find a different cave? But this is what happens when evidence does not fit the accepted timeline. Instead of adjusting the timeline, we come up with increasingly elaborate explanations for why the evidence must be wrong. We protect the narrative. We guard the gates of acceptable interpretation. Here is what I think happened. I think fire control is older than we want to admit. I think it developed gradually, opportunistically, with groups learning to preserve natural fires before they learned to create fire on demand. I think by 780,000 years ago, firekeeping was already an ancient tradition, passed down through enough generations that no one remembered a time before fire. It had become cultural bedrock, part of what it meant to be human, and when the magnetic reversal began, when the world started coming apart, fire became something more than a tool. It became a lifeline. Think about what fire provides. Heat, obviously. Light, absolutely. But also protection. Most predators are afraid of fire. A burning hearth keeps lions and hyenas at bay. In a world where the megafauna were still dominant, where saber-toothed cats and giant hyenas roamed, where early humans were absolutely not at the top of the food chain, fire meant you could sleep without posting guards. Fire meant children were safer. Fire meant you could defend a territory against animals far stronger than you. Fire also meant community. You cannot maintain a hearth alone. It requires cooperation, rotation of responsibilities, shared investment in keeping the flames alive. Sitting around a fire at night changes social dynamics. It creates a focal point. It allows for face-to-face interaction in ways that daylight activities do not. Some anthropologists have argued that the evening hearth was where language truly developed, where storytelling began, where culture in the fullest sense emerged. But there is another aspect of fire that gets overlooked in these discussions. Fire is transformative in ways that go beyond cooking and warmth. Fire can harden wood into spears. Fire can be used to clear land, to drive game, to send signals across vast distances. Fire can crack open bones to access marrow. Fire can render animal fat into fuel. Fire can produce smoke for preserving meat. The people at Gesher Benot Ya'aqov were using fire for multiple purposes. The archaeological evidence shows burning in different contexts, at different temperatures, with different materials. This was not one-dimensional technology. This was a toolkit, a foundation upon which other innovations could be built. And yet, for all we have learned from this site, there is so much we will never know, because the vast majority of what early humans made was organic. Wood, plant fibers, animal hides, bark, reeds, all the materials that decay, that leave no trace, that disappear from the archaeological record within years or decades at most. We find stone tools because stone survives. We find fire sites because burned earth leaves detectable signatures. But what about the wooden digging sticks, the bark containers, the woven baskets, the rope made from plant fibers, the shelters built from branches and hides? All of that existed. All of that was part of their technology. And all of it is invisible to us now. Some archaeologists have estimated that stone tools might represent less than 1% of the actual material culture of Paleolithic peoples. 1%. We are trying to reconstruct an entire way of life from 1% of the evidence. It is like trying to understand modern civilization by looking only at concrete foundations after everything else has rotted away. You would know we built structures. You would not know we had computers, books, clothing, vehicles, or 99% of what makes us human. So when I look at Gesher Benot Ya'aqov, when I see those hearths burning 780,000 years ago, I do not just see fire. I see a shadow, a hint, a glimpse through a keyhole into a world far more complex than the fragments of stone and bone can possibly reveal. I see people who understood their environment in ways we can barely imagine, who knew every plant, every animal, every water source within days of travel in any direction, who could read weather patterns, predict seasonal changes, navigate by stars, who possessed knowledge systems built up over thousands of generations, knowledge that was never written down because writing would not be invented for another 775,000 years. I see survivors, people who looked up at a sky that was trying to kill them and decided that fire, community, and knowledge would be enough to outlast the apocalypse. And they were right. The story you learned in school about human evolution goes something like this. We evolved in Africa. We stayed in Africa for millions of years. Then, somewhere around 60,000 to 70,000 years ago, a small group of modern humans walked out of Africa, spread across the world, and became everyone who is not African today. Clean, simple, linear, one origin, one exodus, one humanity. Except that is not what happened. Not even close. The real story is messier, stranger, and far more interesting. And nowhere is that more apparent than when you start looking at what was happening 780,000 years ago. Because while mainstream textbooks will tell you that the major human migration out of Africa happened relatively recently, the fossil evidence tells a completely different story. A story that gets awkwardly shuffled to the footnotes, mentioned briefly, and then quickly moved past, as if acknowledging it might cause the entire neat narrative to unravel. Let me show you what I mean. In 1991, in the country of Georgia, at a site called Dmanisi, archaeologists uncovered something that should not exist: human fossils, multiple individuals, adults and juveniles, with skull features clearly identifiable as Homo erectus or something very close to it. The dating came back at 1.8 million years old. 1.8 million years. Let that sink in for a moment. These people were not modern humans. They were not even archaic humans. They were something much earlier in the family tree, and they were not in Africa. They were in the Caucasus, at the crossroads between Europe and Asia, nearly 2 million years ago. This discovery shattered the timeline. It meant that human ancestors left Africa far, far earlier than anyone had imagined. It meant that migration was not a one-time event but an ongoing process, something that happened again and again across hundreds of thousands of years. It meant the story we had been telling about human origins was fundamentally incomplete. Now, you might expect a discovery this significant to completely reshape how we teach human evolution. You might expect textbooks to be rewritten, documentaries to be updated, the entire narrative to shift. And to some degree, that has happened. Dmanisi is acknowledged, it is mentioned, but it is treated as an outlier, an early experiment that did not really matter in the long run. The focus remains on that later migration of modern humans, the one that supposedly counts, but here is the problem. Dmanisi is not an outlier. It is part of a pattern. In China, at sites like Gongwangling and Lantian, fossils of Homo erectus have been dated to 1.6 million years ago. In Indonesia, on the island of Java, erectus remains go back at least 1.5 million years, possibly older. These were not isolated wanderers who got lost and died out. These were successful populations that established themselves across an enormous geographic range and persisted for over 1 million years. So, if humans were already out of Africa nearly 2 million years ago, what was happening at 780,000 years ago? Why does that particular time period matter? Because something changed. Again. And the evidence suggests another major wave of movement, another expansion, another chapter in the migration story that barely gets mentioned. There are Homo erectus sites scattered across Asia dated to right around this period. Not older, not younger. Specifically around 700 to 800,000 years ago. Sites in China showing sudden appearance of more sophisticated tool technologies. Sites in Java with evidence of population expansion. Sites in the Middle East, like Gesher Benot Ya'aqov, showing intensive occupation exactly at this time. Why then? What happened 780,000 years ago that triggered movement? Climate is the easy answer. Glacial cycles were shifting. Some regions became uninhabitable while others opened up. Sea levels dropped during glacial periods, creating land bridges that did not exist before. The Bab el-Mandeb Strait between Africa and Arabia, normally a significant water barrier, would have narrowed dramatically. Indonesia would have been connected to mainland Asia by a continuous landmass called Sundaland. Migration routes appeared and disappeared based on ice, water, and vegetation patterns. But climate had been shifting for millions of years. Glacial cycles had come and gone dozens of times. Why would this particular period be special? Unless it was not just about climate. Unless the magnetic reversal played a role, here is a possibility that does not get discussed in academic papers. What if the radiation bombardment caused by the weakened magnetic field made certain regions more dangerous than others? Earth's magnetic field is not uniform. It has always had stronger and weaker regions depending on the underlying geology. During a reversal, those weak spots would become even weaker, essentially creating zones of higher radiation exposure. If you were a population of early humans trying to survive, and if you noticed that people living in certain areas got sick more often, had more children born with problems, had shorter lifespans, would you stay there? Or would you move? Would you follow the routes that seemed safer, that led away from the bad zones? This is pure speculation. I want to be clear about that. We have no direct evidence that early humans understood or responded to differential radiation exposure. But we also know they were not stupid. They were observers. They noticed patterns. They made decisions based on what worked and what did not. And if entire populations started moving around 780,000 years ago, right when the magnetic field was at its weakest, is it really so crazy to think there might be a connection? What frustrates me about mainstream archaeology is the reluctance to even consider these possibilities. The default assumption is that early humans were reactive, not proactive, that they just followed the food and the weather and had no deeper understanding of cause and effect, that they were sophisticated enough to control fire, hunt elephants, and make complex tools, but somehow too primitive to notice that the sky was doing weird things and people were getting sick. That does not add up. And then there is the other uncomfortable question. If humans were spreading across Asia and the Middle East 780,000 years ago, and if populations were under enormous stress from the magnetic reversal, what happened to the groups that did not make it? The ones that chose the wrong route, settled in the wrong region, failed to adapt quickly enough? They disappeared. Obviously, we know there was a genetic bottleneck. We know populations crashed. But here is what we do not know. How many distinct human groups existed before the bottleneck? How genetically and culturally diverse was early humanity? Did we lose entire branches of the family tree, entire ways of being human during this period? The genetic evidence suggests yes. Modern humans, Neanderthals, and Denisovans all share a common ancestor who lived somewhere between 500,000 and 800,000 years ago. That means that before this split, there was a parent population, and that parent population was likely far more diverse than the descendant lineages that survived. We lost that diversity. Somewhere in the chaos of the magnetic reversal, the climate shifts, the population crashes, we went through a genetic funnel. Most variations were filtered out. Only a few lineages made it through. Now, here is where things get controversial. There are researchers, fringe figures mostly, not accepted by mainstream institutions, who argue that the archaeological establishment has systematically ignored or downplayed evidence of very early human presence outside Africa, that there are sites in Europe, Asia, even potentially the Americas, that are far older than officially acknowledged, that these sites get dismissed or explained away because they do not fit the approved narrative. I am not going to sit here and tell you that humans were in the Americas 780,000 years ago. The evidence for that is weak to non-existent. But I will say this, there are sites that make me uncomfortable, anomalies that do not fit. Stone tools in California, dated to 130,000 years ago, dismissed by most archaeologists as natural rock fractures. Possible hearth sites in Brazil, dated to 48,000 years ago, older than humans, were supposedly in the New World. Controversially dated sites all over the world that get rejected not because the dating methods are flawed, but because the dates are impossible according to the accepted timeline. Maybe those dates are wrong. Contamination happens. Geological processes can mimic human activity. I'm not saying we should accept every controversial claim uncritically, but I am saying we should be suspicious of any field that refuses to seriously engage with evidence that contradicts its core assumptions. That is not science. That is dogma. The real story of 780,000 years ago is that humans were on the move. Multiple populations, in multiple directions, responding to pressures we can only partially reconstruct. Some of those populations made it, some did not. The ones that survived were the ancestors of everyone who came after, but they were not the only players in the game. They were just the lucky ones. And luck, in the context of a magnetic apocalypse, might have come down to being in the right place at the right time. Taking the route that led through lower radiation zones, ending up in a region with caves deep enough to provide shelter, having access to resources that allowed for fire maintenance, being part of a group with the knowledge and social cohesion to make it through thousands of years of environmental chaos. The hidden exodus was not one dramatic march out of Africa. It was a slow, grinding dispersal driven by desperation and opportunity in equal measure. It was people following rivers, coastlines, animal migrations. It was populations splitting, some going north, some going east, some staying put and trying to weather the storm where they were. Most of them died. Their genetic lines ended. Their knowledge was lost. Their stories were never told. But a few made it, and 780,000 years later, we are the proof. There is a skull sitting in a museum in Addis Ababa that nobody talks about enough. It belonged to someone who lived approximately 600,000 years ago in what is now Ethiopia. When you look at photographs of it, the first thing that strikes you is how familiar it appears. The cranial capacity is over 1,300 cubic centimeters. That is within the range of modern humans. The face is less projecting than earlier hominins. The brow ridges, while still prominent, are reduced compared to classic Homo erectus. This person was not quite us. But they were getting close, very close, and they lived 400,000 years before our species, Homo sapiens, supposedly evolved. Something profound happened between 800,000 and 600,000 years ago. Something that started with brains the size of a large grapefruit and ended with brains approaching the size they are today. A transformation compressed into an evolutionary instant. 200,000 years sounds like a long time until you remember that Homo erectus existed for nearly 2 million years with relatively little brain size change. So what flipped the switch? What turned slow, gradual evolution into rapid, dramatic change? The standard explanation involves a feedback loop. Larger brains allowed for better tool making and social coordination. Better tools and social structures provided advantages that selected for even larger brains. Add in the expensive tissue hypothesis, the idea that cooking freed up energy previously needed for digestion, and you have got a story that explains itself through normal evolutionary mechanisms. But that explanation has always felt incomplete to me. Not wrong, necessarily, but inadequate. Because it does not explain the timing. Why then? Why not a million years earlier? Why not 500,000 years later? What made the period between 800,000 and 600,000 years ago so special that it triggered the most dramatic neurological transformation in the history of primates? You already know where I am going with this. The magnetic reversal, the radiation, the population bottleneck, all the pieces we have been building toward. But before you dismiss this as fringe speculation, let me walk you through what we actually know about radiation and evolution, because this is not pseudoscience. This is established biology. Ionizing radiation causes mutations by damaging DNA. This is basic physics. High-energy particles slam into cells, breaking chemical bonds, creating free radicals that wreak havoc on genetic material. Most of the time, the damage gets repaired. Cells have sophisticated mechanisms for fixing broken DNA, but sometimes the repairs are imperfect. Sometimes the mutations stick, and occasionally, very rarely, those mutations provide an advantage. This is how evolution works at the molecular level. Random mutation plus natural selection. The mutation rate determines how quickly new variations appear. The selection pressure determines which variations survive. Increase the mutation rate dramatically. Apply intense selection pressure, and evolution accelerates. This is not theoretical. We have observed it in laboratory conditions. We have mathematical models that predict it. We understand the mechanisms. Now, apply this to 780,000 years ago. Cosmic radiation levels 10 times higher than normal, sustained for thousands of years. A human population reduced to a few thousand individuals, living in caves, struggling to survive. Intense selection pressure favoring any trait that provided an edge. Intelligence, planning ability, social coordination, resistance to radiation sickness, better DNA repair mechanisms. The pieces fit almost too well, which is probably why this idea makes mainstream academics so uncomfortable. Because if you accept that the magnetic reversal might have accelerated human brain evolution through increased mutation rates, you are accepting that our intelligence, the thing that makes us human, might be the result of a cosmic accident. A lucky roll of the evolutionary dice, not inevitable progress toward greater complexity, but contingent survival through catastrophe. That is a hard pill to swallow if your worldview requires that humanity is the pinnacle of evolution, the inevitable outcome of a process that always trends toward greater consciousness. But let me push this even further, because brain size is only part of the story. What matters more is what those brains were doing. And this is where the archaeological record gets really interesting. Around 700,000 years ago, we start seeing evidence of what archaeologists call behavioral modernity. Not full modernity, not yet, but the foundations. Fire control? Yes. Long-distance resource transport? Yes. But also something more subtle, something that shows up in how tools are made. Acheulean hand axes, the characteristic tool of Homo erectus, had been around for over 1,000,000 years. They are remarkably consistent across vast geographic ranges and enormous spans of time. Same basic shape, same basic function, minimal variation. Then, around 700,000 years ago, they start to change. They become more refined, more symmetrical. Some researchers have argued they become unnecessarily beautiful, showing aesthetic concerns beyond pure function. Why would someone spend extra time making a tool more symmetrical if symmetry provides no practical advantage? Why add refinements that cost energy but do not improve cutting efficiency? The answer might be that these tools were not just tools. They were signals, demonstrations of skill, markers of identity, evidence of a mind that cared about things beyond immediate survival. A mind capable of symbolic thought. Symbolic thought is what separates us from every other animal on the planet. It is the ability to let one thing represent another thing, to understand that a sound can represent an object, that a mark on a surface can carry meaning, that a shaped stone can communicate something about the person who shaped it. Language is symbolic thought. Art is symbolic thought. Culture is symbolic thought. And all of it requires a brain wired in a very specific way, with connections between regions that allow for abstract representation. When did that wiring develop? We do not know. Language does not fossilize. Thoughts do not leave traces. We can only infer from indirect evidence. Tool complexity, site organization, evidence of ritual or ceremony. And all of those things start appearing tentatively at first, around the period we are talking about. There is a site in Zambia called the Twin Rivers site, where archaeologists found pigment processing dating back 230,000 years. Chunks of red and yellow ochre, ground into powder, used for purposes we can only guess at. Body decoration, maybe. Symbolic marking. Some kind of proto-art. But here's the thing. The cognitive capabilities required to do this, to see a colored rock and think I can grind this into powder and use it to change how something looks, those capabilities do not appear overnight. They develop gradually. They require a foundation. What if that foundation was being laid 780,000 years ago? What if the brains that were forming during the magnetic reversal were brains pre-adapted for symbolic thought, even if the full expression of that ability would not emerge for hundreds of thousands of years? Evolution does not work toward future goals. It cannot plan ahead, but it can produce structures that later get co-opted for new purposes. Bird feathers originally evolved for temperature regulation, not flight, but once they existed, flight became possible. Maybe the neurological rewiring that happened during the magnetic reversal, driven by immediate selection pressures like spatial memory and social coordination, created a brain architecture that later, much later, allowed for language and abstract thought. This is all speculation, of course. We cannot scan the brain of someone who lived 780,000 years ago. We cannot run experiments. We cannot definitively prove any of this. But there are clues, strange, suggestive clues that keep surfacing despite attempts to explain them away. There is the Flynn effect, the observation that IQ scores have been rising consistently across generations in modern populations. It is attributed to better nutrition, more education, reduced disease burden. But what if it is also revealing something about human cognitive potential? What if our brains are more plastic, more responsive to environmental conditions than we thought? What if the period of rapid brain expansion 780,000 years ago was not just about size, but about creating a highly adaptable neural substrate that could be shaped by culture and environment? There is also the observation that human brain size has actually decreased slightly over the last 20,000 years. We are a bit less brainy than our immediate ancestors. Some researchers think this is about efficiency, about brains getting better at doing more with less. Others think it is about reduced selection pressure once we developed agriculture and complex societies. But what if it is revealing that brain size alone does not determine intelligence? That what matters is connectivity, organization, the software, not the hardware. And then there are the genetic studies looking at brain development genes. Genes like ASPM and microcephalin, which regulate brain growth, show evidence of positive selection in human lineages within the last few 100,000 years. The timing is fuzzy, the confidence intervals are broad, but multiple studies point to a period of accelerated change overlapping with the era we are discussing. None of this proves that cosmic radiation caused a cognitive revolution, but it all points to the same conclusion. Something happened between 800,000 and 600,000 years ago that fundamentally changed what it meant to be human. The environment was hostile, the population was small, the selection pressure was extreme, and somehow, instead of going extinct, we became smarter. Maybe it was cooking, maybe it was social cooperation, maybe it was normal, gradual evolution that just happened to accelerate during a crisis. Or maybe, just maybe, it was the sky itself bombarding us with radiation, forcing mutations that would have taken millions of years to occur naturally, filtering brutally for any variation that helped survive the apocalypse. We survived, but we did not survive unchanged. We came out the other side with bigger brains, better tools, and the cognitive foundation for everything that would follow. Language, art, science, civilization, all of it tracing back to ancestors who looked up at a broken sky, retreated into caves, kept fires burning, and somehow, against impossible odds, thought their way to survival. That is not the story they teach in schools. That is not the clean, simple narrative of gradual progress. That is a story of catastrophe and contingency, of humanity forged in crisis, of intelligence as scar tissue. But I think it might be closer to the truth. Walk into any museum with a Paleolithic collection and you will see the same thing. Stone tools, rows and rows of stone tools, hand axes, scrapers, blades, cores, all stone. Museums love stone because stone survives. It sits in the ground for 1,000,000 years and comes out looking more or less the same. You can hold it, photograph it, put it behind glass with a little placard explaining what it is. But here is what you will not see. You will not see the wooden spear shafts those stone points were attached to. You will not see the plant fiber bindings that held them together. You will not see the carrying bags woven from grass. You will not see the digging sticks, the throwing sticks, the baby slings, the cordage, the baskets, the mats, the shelters, or 99% of what people actually made and used, because wood rots, fiber decays, hide and sinew and bark and leaves all disappear within years, sometimes months, of being abandoned. The archaeological record is not a window into the past. It is a keyhole, and we are trying to reconstruct an entire world by squinting through it at the few scraps that happen to not decompose. This is the problem with understanding technology 780,000 years ago. We are not seeing the technology. We are seeing the 1% of technology that accidentally survived. And then we are making sweeping claims about the cognitive abilities and cultural sophistication of people based on that 1%. It is like aliens landing on Earth 1,000,000 years from now, finding nothing but concrete foundations and glass shards, and concluding that humans were primitive creatures who only knew how to make rectangular structures and sharp, transparent objects. Everything else, the computers, the books, the vehicles, the art, all of it gone. rotted away or rusted into dust. So when I think about what the people at Gesher Benot Ya'aqov were actually doing 780,000 years ago, I do not just think about the stone tools they left behind. I think about everything they must have made that we will never see. Start with the obvious. Wooden tools. Modern hunter-gatherer societies make extensive use of wood. Digging sticks for excavating roots and tubers. Spears for hunting. Throwing sticks for bringing down birds. Clubs for close combat. Handles for stone tools. Pegs and stakes for shelters. Wood is everywhere in the toolkit. It is lighter than stone, easier to work, and can be shaped into forms that stone cannot match. There is no reason to think people 780,000 years ago were not doing the same thing. In fact, we have direct proof. In 1995, archaeologists in Germany found wooden spears at a site called Schöningen, dated to around 300,000 years ago. These were not crude sticks. These were engineered weapons, carefully carved from spruce, balanced for throwing, with the center of gravity positioned exactly where it needed to be for maximum aerodynamic stability. Javelins that would have been effective against large game at distances of 20 to 30 meters, 300,000 years ago. That is less than half the age of Gesher Benot Ya'aqov. So what were people making with wood at 780,000 years ago? We will probably never know, because the preservation conditions that allowed the Schöningen spears to survive are vanishingly rare. But the cognitive capacity was there, the manual dexterity was there, the understanding of leverage, balance, and material properties was there. They were making sophisticated wooden tools, tools that have vanished completely from the record, tools that would make the stone implements we obsess over look crude by comparison. Now, go further. Plant fiber technology. This is one of the oldest technologies on Earth, possibly predating stone toolmaking. Twisting plant fibers into cordage, weaving cordage into nets and baskets, using plant materials to create containers, shelters, clothing. This is not speculation. We know people were doing this because when conditions are right, when preservation is perfect, we find it. The oldest known cordage comes from the Ohalo II site in Israel, dated to 19,000 years ago. Twisted flax fibers. Before that, we have nothing. Does that mean cordage was only invented 19,000 years ago? Of course not. It means cordage older than 19,000 years has not survived or has not been found yet. But people at Gesher Benot Ya'aqov had hands identical to ours. They had cognitive abilities sophisticated enough for fire control and coordinated hunting. You are telling me they never figured out that twisting plant fibers together makes them stronger? That they never wove a simple basket? That they carried everything in their hands for hundreds of thousands of years until some genius in the late Paleolithic suddenly invented the concept of a container? That is absurd. They had containers. They had cordage. They had woven materials. It has just all disappeared. And this creates a massive blind spot in how we understand early human behavior. We judge technological sophistication based on stone tools, but stone tools might have been the boring, utilitarian part of the toolkit, the everyday stuff, the equivalent of a modern screwdriver. Useful, necessary, but not particularly innovative. The real technology, the stuff that required serious skill and knowledge, might have been entirely organic, and we are missing it, all of it. Let me give you an example that should bother you. Ethnographic studies of modern hunter-gatherers show that women's activities typically involve extensive plant processing, gathering roots, tubers, seeds, nuts, fruits, preparing these foods through grinding, soaking, heating, making containers to carry them, making tools to process them. In most hunter-gatherer societies, women's plant gathering provides 60 to 70% of the caloric intake. But in the archaeological record, we barely see this. We see stone tools used for hunting, for butchering animals, for processing meat. We see the activities that leave durable traces, the activities coded as male in our cultural assumptions. And we conclude that hunting was the dominant subsistence strategy, that meat was the primary food source, that men's activities drove human evolution. What if we are completely wrong? What if plant processing was always the foundation of the diet, and we just cannot see it because wooden digging sticks and fiber baskets do not fossilize? What if women's technological innovations, passed down through generations, were just as sophisticated as anything related to hunting, but have been rendered invisible by the selective preservation of the archaeological record? This is not a political statement. This is a methodological problem. We are building theories about human behavior on evidence that is systematically biased towards certain types of activities and certain types of materials, and then we are treating those theories as definitive. Here's another thing we are missing: pharmacology, the use of plants for medicinal purposes. Modern indigenous peoples have encyclopedic knowledge of plant properties: which plants reduce fever, which plants treat infections, which plants ease pain, which plants induce vomiting to clear poisons. This knowledge is staggeringly complex and takes lifetimes to accumulate. Did people 780,000 years ago have this knowledge? We have no idea. Medicinal plant use does not leave archaeological traces unless we get incredibly lucky with preserved gut contents or residues on tools. But the cognitive capacity was there. The observational skills were there. And given that they were living through a period of elevated radiation, increased mutation rates, and likely higher disease burden, they would have had strong incentive to figure out which plants made people feel better. There are hints. Palynology, the study of ancient pollen, sometimes shows unusual concentrations of specific plant species at habitation sites. Plants that do not grow naturally in those areas. Plants that had to be brought there deliberately. Why? For food? Probably. But maybe also for medicine. Maybe also for ritual purposes. We do not know. We can only speculate based on what modern peoples do with similar plants. And then there is fermentation. This is one of my favorite examples of lost technology because we know it is ancient, but we have no idea how ancient. Fermentation is what happens when microorganisms break down sugars into alcohol or acids. It preserves food. It makes nutrients more bioavailable. It produces compounds that can alter consciousness. Every human society that has been studied practices some form of fermentation. Beer, wine, bread, cheese, yogurt, fermented vegetables, fermented meat. This is universal, which suggests it is old, really old. But the oldest direct evidence we have for intentional fermentation is only about 9,000 years ago, from early agricultural societies in China and the Middle East. 9,000 years. That is nothing. That is practically yesterday. Are we really supposed to believe that for hundreds of thousands of years, humans never noticed that fruit left sitting around starts to smell funny and makes you feel strange when you eat it? Never figured out that this process could be controlled and used deliberately? Someone was making alcohol 780,000 years ago. I would bet my reputation on it. Not beer or wine, probably, but fermented fruit juice, fermented honey if they could get it, something. Because the neurological reward pathways that make alcohol pleasurable are ancient. They predate humanity. Other primates seek out fermented fruit. They know what it does and they like it. Why would early humans be any different? But fermented beverages leave no trace. Unless we find residues in a container, and unless that container happens to be in perfect preservation conditions, and unless we happen to test for the right compounds, we will never know. So here is what I think was actually happening 780,000 years ago. I think people had a material culture of staggering complexity, built entirely from organic materials, sophisticated wooden tools, woven fiber containers and cordage, processed plant foods that required specialized knowledge to make edible, medicinal plants, possibly fermented beverages, carefully constructed shelters using wood frames and plant materials, clothing or at least wrappings made from hide or fiber. All of this existed. All of it was essential to survival, and exactly none of it survived. What we are left with is stone tools. Important, yes, but maybe not representative. Maybe not even the most interesting part of the technological repertoire. And if we are this wrong about technology, what else are we wrong about? What other aspects of early human life have we systematically misunderstood because the evidence is invisible? Picture an elephant. Not a modern elephant, though they are impressive enough. Picture a straight-tusked elephant, Paleoloxodon antiquus, standing 4 meters tall at the shoulder, weighing somewhere between 10 and 13 tons. Tusks 3 meters long, curving forward like massive spears made of ivory. An animal so large that adult males had essentially no natural predators. Nothing hunted them. Nothing could, except us. At Gesher Benot Ya'aqov, Mixed in with the burned wood and stone tools and evidence of controlled fire, archaeologists found bones, lots of bones, elephant bones, and not just random scattered remains. These were butchery sites, places where elephants had been systematically dismembered, their meat stripped away, their bones cracked open for marrow, their tusks and skulls processed. Multiple individuals, multiple events, a pattern repeated over thousands of years. 780,000 years ago, people were killing elephants, regularly, successfully. Animals that weighed 50 to 60 times what a human weighed. Animals with thick hide that stone tools could barely penetrate. Animals that could crush a person with a single step or gore them with tusks longer than a man was tall. How do you kill something like that with Paleolithic technology? How do you even attempt it without getting everyone in your group killed in the process? The answer is you do not fight an elephant head-on. You cannot. You are not strong enough, not fast enough, not well-armed enough. If you try to go toe-to-toe with an animal that size, you die. Every time. So you do not fight it. You hunt it. And hunting is not about strength. Hunting is about intelligence. Let me walk you through what elephant hunting probably looked like 780,000 years ago, based on what we know from the archaeological evidence and from ethnographic studies of modern peoples who hunt large game. First, you need to find the right elephant. Not just any elephant. You are looking for a specific individual, maybe one that is old or injured, maybe one that has separated from the herd, maybe a young adult that is big enough to provide substantial meat but not so experienced that it will be impossible to approach. You are observing. You are tracking. You are following this herd for days, maybe weeks, learning their patterns, watching how they move, identifying which individual is your target. This requires extensive ecological knowledge. You need to understand elephant behavior, their social structures, their seasonal movements, their water requirements. You need to know the landscape intimately, where the trails are, where the narrow passages are, where the soft ground is that might slow a fleeing animal. This is not something one person knows. This is collective knowledge, accumulated over generations, passed down through demonstration and storytelling. Once you have identified your target, you need a plan. And this is where it gets interesting, because the archaeological evidence suggests that people were using fire as a hunting tool. At sites across Africa and the Middle East from this period, we find evidence of landscape burning, of fires set deliberately in patterns that do not match natural fire behavior. These are controlled burns, likely used to drive game, to funnel animals toward specific locations, to alter vegetation patterns over time. Imagine using fire to slowly, over hours or days, drive a herd of elephants toward a specific area. Maybe toward a bog or marsh where their weight will cause them to sink. Maybe toward a narrow ravine where their mobility is restricted. Maybe toward a cliff edge. You are not chasing them. You are guiding them, using smoke and flame to create barriers they will not cross, paths they will naturally follow. And then, when the target animal is in position, isolated from the herd, in terrain that favors you, you strike. Not with a frontal assault, with projectiles from a distance. Spears, probably tipped with stone points, thrown or thrust at vulnerable areas. The eyes, the mouth, the soft tissue behind the front legs where arteries run close to the surface. You are not trying to kill it immediately. You are trying to wound it, to make it bleed, to slow it down, and then you wait. You follow at a safe distance as the elephant weakens. Hours, maybe days. Bleeding, tiring, unable to keep up with the herd. Eventually it stops, unable to run anymore, and that is when you move in for the kill. Still carefully, still coordinated. Multiple hunters approaching from different angles, delivering wounds until the animal finally collapses. This is not sport. This is not adventure. This is calculated, methodical, dangerous work that requires every member of the hunting party to know their role, to trust each other completely, to execute a plan that has been refined over countless hunts. One mistake and people die. One moment of panic, one person out of position, and a 13-ton animal is coming at you with nothing between you and death except your ability to run faster than you have ever run in your life. The fact that people at Gesher Benot Ya'aqov were doing this successfully, repeatedly, tells us something profound about their cognitive and social capabilities. This is not opportunistic scavenging. This is not stumbling across a dead animal and taking advantage. This is strategic hunting requiring forward planning, abstract thinking, sophisticated communication, and social coordination at a level that we previously did not think existed until much, much later in human evolution. But here is where things get darker. Here is where we need to talk about something that archaeologists whisper about but rarely put in their published papers. There is too much elephant, too many kill sites, too many bones. More than what a small population of humans could possibly consume before the meat rotted. Sites where elephants were butchered, and then significant portions of the carcass were left behind. Waste, surplus killing. Animals killed not because they were needed, but because they could be. Modern humans do this. Sport hunters kill for trophies. Fishing boats dump bycatch. We have this ugly tendency to kill more than we need when we have the means to do so. It is wasteful. It is ecologically destructive. And apparently, it is very old behavior. Some researchers have suggested that early humans might have played a role in megafauna extinctions far earlier than we usually acknowledge. The standard story is that the big extinction events happened relatively recently, 10 to 15,000 years ago, as modern humans spread across the globe. But what if it started earlier? What if humans have been impacting large animal populations for hundreds of thousands of years? This is controversial because it contradicts the narrative of ancient peoples living in harmony with nature, taking only what they needed, maintaining ecological balance. We like that narrative. It is comforting. It makes indigenous knowledge systems seem pure and untainted by the wastefulness of modern civilization. But the evidence does not support it. The evidence suggests that humans, as soon as they developed the technology to kill large animals efficiently, started killing them in numbers that exceeded subsistence needs. Maybe for ritual purposes, maybe for social status, maybe just because they could. The motivations do not matter. The impact does. And if you are an elephant population already stressed by climate change, by habitat fragmentation, by the environmental chaos of a magnetic reversal, and suddenly you have a new predator that can kill even the largest adults, a predator that is learning and adapting and getting better at it with each generation, your population is in serious trouble. We do not have good population data for megafauna from 780,000 years ago. The fossil record is too spotty. But we do know that many species that were widespread and abundant at that time were gone or severely reduced by 500,000 years ago. Some of that was climate, some of that was habitat loss, but some of it, maybe a significant portion, was us. Here is the uncomfortable truth. Humans have been apex predators for a very long time, and apex predators change ecosystems. We did not just adapt to the world as it was, we changed the world to suit us. We burned landscapes to create the mix of forest and grassland that favored the prey species we hunted. We eliminated predators that competed with us. We drove prey populations up and down through our hunting pressure. We were ecosystem engineers, shaping the environment through our activities. This started at least 780,000 years ago, probably earlier. And once it started, it never stopped. Every habitat humans have ever entered has been transformed by our presence. Sometimes subtly, sometimes dramatically, but always changed. The people at Gesher Benot Ya'aqov were not living in harmony with nature. They were dominating it, bending it to their will, using fire and coordinated hunting to reshape the landscape into something that served their needs. They were successful, incredibly successful, so successful that they fundamentally altered the ecology of the region. And this success, this ability to kill animals far larger than themselves, to manipulate landscapes with fire, to coordinate complex group activities towards shared goals, this was part of what made them human. Not noble savages living in balance, not innocent children of nature. Apex predators with the cognitive tools to dominate every environment they entered. That is who we descended from. That is what 780,000 years of evolution has made us. And whether we like that story or not, it is the story the bones tell. The North Magnetic Pole is currently moving across the Arctic at about 34 miles per year. That is up from 9 miles per year in the early 2000s. It has accelerated by almost 400% in 2 decades. If you are using a compass for navigation, You need to recalibrate more frequently than your grandparents did because the pole is not where it used to be. It is racing toward Siberia, and nobody knows when or if it will stop. Earth's overall magnetic field strength has declined approximately 9% over the last 200 years. Some regions, particularly the South Atlantic anomaly, have weakened by as much as 25%. Satellites passing through this region experience increased computer glitches and hardware failures. The International Space Station has to power down certain instruments when transiting the anomaly to avoid damage. These are not predictions. These are not models. These are measurements. This is happening right now. And the question that nobody in authority wants to address directly is this: are we heading toward another reversal? Another period like 780,000 years ago when the magnetic field collapsed and cosmic radiation bathed the planet for thousands of years? The official answer from NASA, NOAA, and other scientific institutions is cautious to the point of evasiveness. Yes, the field is weakening. Yes, the poles are moving. Yes, reversals happen periodically throughout Earth's history. But reversals take thousands of years to complete, and there is no evidence we are in imminent danger, and by the time anything serious happens, we will have developed technology to deal with it. That last part is the one that bothers me. The assumption that technology will save us, the faith that future innovations will solve problems we cannot even fully articulate yet. It is the same mentality that has gotten us into every environmental crisis we currently face. Assume the problem is manageable. Assume we will figure it out later. Assume that humans are smart enough to engineer our way out of any corner we back ourselves into. Maybe we are. Maybe we will develop magnetic shielding or underground habitats or genetic therapies that protect against radiation damage. Maybe. But 780,000 years ago offers a different lesson. It suggests that when the world falls apart, technology alone is not enough. What saved our ancestors was not superior tools, though tools helped. What saved them was knowledge, social cohesion, the ability to cooperate across generations, the willingness to preserve and transmit information even when the immediate payoff was not obvious. They kept fires burning. They remembered which caves provided the best shelter. They maintained hunting strategies that took years to teach and lifetimes to master. They passed down stories about the sky and the seasons and the animals and the plants. And when the crisis was over, when the magnetic field stabilized and radiation levels dropped, that accumulated knowledge allowed them to rebuild, to spread, to thrive. We have lost that. Not the technology. We have more technology than any society in history. But the knowledge systems that exist outside of technology, the intergenerational wisdom, the ecological understanding, the ability to survive without electricity and supply chains and global infrastructure, that has atrophied. How many people today could start a fire without matches or a lighter? How many could identify edible plants in their local environment? How many could track an animal, build a shelter, find water, navigate without GPS? These were universal skills for most of human history. Now they are hobbies, survival skills practiced by enthusiasts, not baseline competencies that everyone possesses. This is not nostalgia for some imagined past. I am not suggesting we should all abandon modern life and return to caves. I am suggesting that we have become dangerously dependent on systems that are far more fragile than we like to admit. And if those systems fail, if a solar storm takes out power grids, if a magnetic reversal disrupts satellites and electronics, if any of a dozen possible catastrophes force us to survive without the infrastructure we take for granted, most people would not last a week. Our ancestors survived an apocalypse because they had redundancy built into their knowledge systems. They did not rely on a single technology or a single food source or a single environment. They were generalists, adaptable, resilient. We have specialized ourselves into a corner. We are incredibly good at thriving in the specific conditions we have created. But if those conditions change, we are in trouble. And here is the parallel that keeps me up at night. The people living 780,000 years ago did not know they were heading into a crisis. The magnetic reversal happened slowly, over generations. By the time it was obvious that something was seriously wrong, they were already deep into it. No time to prepare. No time to develop new technologies or strategies. They had to survive with what they already knew, what they had already built, what their ancestors had already passed down. We are in the same position. If the magnetic field is heading toward a reversal, the process has already started. We are already in the early stages, and we are spending our time arguing about whether it is real, whether it matters, whether we should do anything about it, instead of preparing for what might be coming. Maybe I am wrong. Maybe the field will restabilize. Maybe this is just normal fluctuation and not the beginning of a reversal. I hope that is true, but hope is not a strategy, and betting our survival on the assumption that everything will work out fine is exactly the kind of thinking that gets species killed. The archaeological record is full of societies that collapsed because they could not adapt quickly enough to changing conditions. Climate shifts, resource depletion, environmental degradation, the proximate causes vary, but the underlying pattern is the same. Societies become dependent on specific conditions. Those conditions change. The society cannot adjust fast enough. Collapse follows. We are not immune to this. We are not special. We are not guaranteed survival just because we have smartphones and space stations and global communication networks. Those things make us powerful in stable conditions. They might make us more vulnerable when conditions become unstable. So, what do we do? How do we prepare for something that might happen in 50 years or 500 years or might not happen at all? We remember. We preserve knowledge. We maintain skills that seem obsolete. We build resilience into our systems instead of optimizing everything for maximum efficiency. We acknowledge that the future might not look like the present, and we prepare accordingly. And we study the past, not just the parts that make us look good, not just the triumphant march towards civilization, but the messy, terrifying, contingent parts, the times when everything almost ended, the times when survival came down to knowledge, cooperation, and sheer stubborn refusal to give up. 780,000 years ago, the world tried to kill us. Cosmic radiation, climate chaos, ecological collapse, population crash. We should have gone extinct. By every reasonable metric, we should have died out along with dozens of other species that did not make it through that period. But we did not. We survived. And not just survived, but emerged stronger, smarter, more capable than before. We turned catastrophe into evolution. We used crisis as a crucible. That is the real lesson. Not that everything will be fine. Not that technology will save us. But that humans, when pushed to the edge, have this remarkable capacity to adapt, to innovate, to find ways forward that nobody imagined were possible. We did it before. In caves, around fires, during the worst environmental crisis our species has ever faced. We can do it again, but only if we remember, only if we learn, only if we have the humility to recognize that we are not the endpoint of evolution. We are just another chapter in a story that is still being written. The sky is changing. The magnetic field is shifting. History is not over. And what we do in the next few decades, the choices we make about preparation and resilience and knowledge preservation, might determine whether our descendants look back at us the way we look back at those firekeepers 780,000 years ago, as the ones who saw the crisis coming and did what needed to be done, or as the ones who were too arrogant, too comfortable, too convinced of our own invincibility to prepare for what we should have seen coming. 780,000 years from now, will there be anyone left to tell our story? That depends on what we do right now. That is the parallel. That is the warning. That is why this matters. Because the cycle repeats. And we are in it, whether we want to be or not. This was just the beginning. Next time, we are going deeper into what conventional archaeology refuses to discuss, the tools that should not exist, the sites that do not fit the timeline, the evidence that keeps getting explained away. Because if 780,000 years ago taught us anything, it is that the official story is never the whole story.